Okay, good afternoon, and thanks for joining us today in this session, RAG System in Research, where Bogdan has mentioned some inaccurate details about what we're going to cover today, but I'll correct that in just a minute. So, in the next 1 hour, you will learn what is retrieval-augmented generation is, how it works in very simple terms, and you should be able to decide at the end if it's something that is useful for your research or not. And you should also be able to decide if it's something that's worth for you investigating and learning more about. My name is Futoon Abushaqra, and I am a research fellow in Australian Internet Observatory, a member of ADMS Center, and offering lecturer in RMIT University. With me here, we have the expert guy in RAG and LLM. This is Sachin. He worked as a researcher in a privacy and resilience hub in RMIT. Okay. Before we get started, I would like to acknowledge the traditional owner of the land in which we are meeting today. Today we are meeting in Narm. This is the traditional name of Melbourne that has been taken care of by Woi Wurrung and Poon Wurrung people. I would like to pay my respects to them and to all of the traditional custodians of the country throughout Australia. The outlines for today. We're going to start with a simple story that will make you connected to the topic and give you some context. And then with Sachin, you will get into a little bit technical details of how a RAG system works. You're not going to learn how to build it, but you should be able first to understand what is it, what its limitation, what it's capable for, and then it's your decision whether it's something useful for your research or not. At the end, we're going to have a group activity that will help you decide if RAG is something that you could use in your research, how you can use it, and where exactly in which part in your research you can use the RAG. Okay, so I think most of you here are a researcher that has worked on data, big data, maybe text document, data from digital platform, social media posts that you have collected, a speech from interview, surveys that you have collected, right? So if that's the case, then this is you. And you have to do this simple research. What did politicians say about immigration in 2022? How you would do that? The simple, very simplest pipeline that you will follow is, it's slow, so it's fine. The first thing, you will collect your data. You might collect data from parliament speeches, press release, social media post, news article, interview transcripts, or maybe more than that. But you will decide what the data is needed and you will collect this data. And then you will simply analyze your data. You might go scan this data manually and these documents manually. You might use some natural language processing tools and methods. You might do concept analysis. You might do semantic analysis. You might combine different methods, but you need to be a little bit of an expert of how you can analyze these documents. And then based on that, you will try to make your findings and make an observation that will help you answer your research question. While going through this pipeline, you are the one in control. You decided what is the data to be used. You decided how you can analyze it. You might have to learn some of the methods to analyze this data, and you find the answers for your question. And you can easily explain based on what you had this answer. Then what if you as a researcher dreamed of, sorry, I missed the limitation. Well, this is a nice pipeline, but it has a limitation. It takes too much time consuming. You have to be an expert in a few things as well. And it's really hard to scale. You cannot add more data whenever you want. That would require more researchers, more resources and more time. You cannot, for example, expand your study to include the last 5 years. And now you're dreaming. Can I use ChatGPT to get an answer for that question? Well, have you thought about that? Yeah. And do you think you can? Oh, no, not yet, not yet. Do you? Yes. Do you think that can work? Well, raise your hand if you wish that would work. Cool.
I wish.
Okay. Well, I have a bad news for you. RAG system. What's going on? Sorry, ChatGPT and other large language model that we have online cannot give you accurate answers because they cannot access your documents. They'll give you answer based on the data they trained on. They don't have that access to the data that you've collected, and you've collected data that might not be public. But maybe you ask people to fill surveys. Maybe you collect social media posts that are private. So you will analyze data that you decided it's useful and you've collected. ChatGPT doesn't have access to that. So even if it answers you, the answer might not be relevant, might not be accurate, and you might not be able to verify if it's accurate or not. Well, is that it? Maybe then, can I give my data that I've collected to ChatGPT and get an answer? What do you think?
Yes, it's just not always going to be the right answer.
Good, that's a correct answer.
I'm tempted to give my data, but again, I don't have the permission, so.
You will have some concerns about privacy. This is the correct answer. Who says no? Well, I would say no, and I have also a correct answer. So, yes, you can give your data to ChatGPT and you might get an answer, but only if your data is a very small 1 or 2 documents. It cannot read a huge amount of documents and give you an answer based on that document. But if you have 1 document and you have 1 perfect query, then you can get an answer and it will be a very accurate answer. But usually that's not the case. The amount of data you have collected already is huge. Okay, so is that it? Or do we have another option? The good news is that we have another option. Can we build our own system that can read all of the data that was collected and give us an answer of our research and analyze this data? The answer is yes, we can. And if we build that system, that will be the RAG system that we will learn about today. This is the difference between the RAG system that we will learn about today and the large language model. The models that are already online and that you usually use, like ChatGPT, Cloudy, Gemini, they have been trained on a data already, on a public data, a huge amount of data. They'll give you answer, but this answer is not based on the data that you have collected. On the opposite, when you build a RAG system, what you do is you connect these large language models that exist with a huge amount of data that you have collected. And the answers that you will be provided from that model is based on the data that you have. And you can ask more specific questions and you can get an answer for something particular. For example, which policy proposal appeared most frequently across this data that you've collected? How did the framing shift between Q1 and Q4 of that year? Okay, that's cool. Let me remember what my next slide would be. Okay, does that sound fantastic? So should we all build a RAG system? Who says yes? Okay, that's good. That's good.
Just for the sake of saying.
Yeah, you already made a decision, and that's not the time yet to make a decision. Because with Sachin, you will see a lot of limitations and where things can go wrong. Okay, before we decide, this is the effort that you spend when you do your research. You want to try to have less effort as much as possible. And this is the control you would have over your research. And we want to stay having control on our research. Usually when we have traditional ways, you are in control because you decided what data is relevant. You've collected this data. You decided how you want to analyze this data. But you also put your effort doing that, and you might have to learn natural language processing to analyze this data. So the traditional way is usually allocated here. You take more effort, but you are in more control. That means at the end, when you find an answer for your question and you make some observation, you can explain based on what you made this information. You can trace back, you can discuss these observations. While if you use large language model, the public models that we have, minimum effort you would have to put, you just have to make a good query, and that's it. But you have zero control. You cannot control based on what this answer is coming. You cannot. It's not easy to verify if it's accurate or not. You cannot change the background. You cannot change what this model has been used to answer your question. And RAG system, just in between of these, you still have to put some effort in building the system, you still have to collect the data that you think is relevant, and it's not going to be a public data. But at the same time, you have some sort of control. You control because you already decided the data. But that's not it. This is not how we decide if RAG is good or not. What about the risk of getting a wrong answer? How we can verify if the response from RAG system is accurate or not? Should I go and check manually? Do I need an answer that is traceable? Is it enough if the RAG system says this answer is based on this page on that document? And if can I just easily check that? Or is the answer a more complicated answer that has been inferred by looking at thousands of or hundreds of documents that you've collected? It's not easy to find out if the answer is accurate or not and trace back these responses. I will stop here, and now, since you now understand RAG in very general ways, now we're going to move to technical details. Sachin will show you what exactly a RAG system is and how it works, what's the pipeline of a RAG system. We will see example of its limitation and what it can break, and then based on that, we will do our group activity.
Thank you. Okay, perfect. Hi, so as Futoon introduced, I'm Sachin. I work in RMIT in the Security and Resilience Hub, focusing on AI agents, search, and other few areas. So retrieval-augmented generation, I think this was in 2022 when a paper came out that became so popular that it just started collecting citations along the ranges of thousands, and is so popular that every organization in the world is starting to employ these to democratize knowledge or information. We'll not go into the details about that. But anyway, so that's why we thought it's important we bring this to, or try to understand how researchers use this. Can they use it? Because it makes a lot of things easier. So how many of you have used Google? Okay, great. And how many of you have noticed the Google overview, AI overview? So that's essentially an example of what a RAG system is. Not a simple example, but there are a lot of things going on in the background, but it is an example. Essentially, what happens there is this. Now, this might look a little overwhelming, but essentially what happens is it's a process that humans follow ourselves. When you want an answer to a question, you essentially go Google them or search for that information, collect information from different documents, put them together, and infer an answer. And that's all that's happening in a RAG system. So essentially, the first step, there is a search, retrieval, where your documents are stored. You get the search results. And the prompt is where you're telling the LLM, hey, this is my question. These are the documents that or the passages that I found are relevant to my query. Can you give me a final answer for this question? And you will see the similarity between this and how we do this on a day-to-day basis if we didn't have RAG. So let's take an example. So before we go on to that, what we did was, I'm assuming all of you know what an open day is. So RMIT had an open day where students, prospective students, come with their parents and ask about the courses, degrees, what they entail, and all of that. So what we did was we actually built a RAG system, gave it access to our internal documents, which talked about these courses. And that's where we actually deployed this and tested. So this is more of a case study example. So one of the questions was what degrees are offered by RMIT Computing School. So in the background, what happens is there is a search, like I mentioned. You get a list of documents, and you pass those search results to an LLM, and you get another set, a final answer. Now, let's verify this answer. So the first one, I'm going to reveal what the problem is over here. If you can read through the final answer and the retrieved results, you'll actually see that because of a problem in the retrieval phase, that is when you searched, you picked the wrong documents, that actually impacted the final response given. So what degrees are offered by RMIT Computing Tech? Essentially, the correct answer is Bachelor of Computer Science, Bachelor of Data Science, and so on. But the final answer refers to, if you can see the blue part, it refers to as Bachelor of Engineering in Computer Science, Software Engineering, and so on. So the blue part that you see there on this in the final answer actually was inferred because there was references to School of Engineering, Bachelor of Engineering degrees in the yellow part, that is a retrieved search results. So this, you see that RAG is not always correct. So there are nuances in these systems that we need to know about before putting them to use, right? So are there any questions about this example? Like, is something confusing here? So something was wrong in the search results, which you passed to an LLM, and LLM gave you a wrong answer because the search results were wrong. Yes.
Are the search results dependent on the LLM then, or on the terms themselves, or on the prompt given?
Excellent question. Thank you. So there are a lot of moving parts here. So the prompt that we mentioned is something that you tell the instruction to the LLM, telling that, hey, this is my user query. These are the search results. Give me an answer. But if you make that prompt more LLM friendly, I guess, meaning giving clear instructions on what you mean by a correct answer, what is correct in this particular case, then the answer would be different. So that is one moving part, prompt. Another moving part is the user query, the query that you type in. If you be more specific about it, the entire generation is going to be different than what you see here. Another moving part is actually how many search results you provide to the LLM. So instead of 3, if I give 10, the LLM is going to infer different answers. And if out of those 10, you give, if out of those 10, 8 of them are wrong, the more chances of getting a wrong answer. So every step of this pipeline has a point where it can go wrong. So it is important to understand each of these when you are judging a RAG system. So this is one example. What I want to show you was a limitation of the RAG system. So let's say the retrieval, the same query, the retrieval was, you got the same results, but you may still get a different answer. And this is the example I spoke about where the LLM itself, you have no control over how the answer is generated. So the LLM may have inferred that blue Over there, can someone tell me what's wrong here? Yes, sure.
Business.
Yes, and this is the typical example of hallucinations that you see, and it can happen in RAG as well, but it gets reduced to a certain extent based on what the retrieval is. So the blue part that you see is not even mentioned in the retrieved portion. Now let's take another one. So there's a retrieved list of 3 documents. You get the answer. Can you tell me what's wrong? What could be wrong here? You get the answer exactly for your question, but something's still wrong here. Thank you. Yes. So this is one of the problems with LLM-based systems. When you get an answer, it may seem complete, but there are contextual information that you're missing out. So for example, there are conditions that you have to, or requirements or nuances behind, for example, the courses at RMIT that needs to be known, that is missing, even if it's retrieved appropriately. So now what happens is the LLM is, or the system is trying to answer your question to exactly to the point, but it's missing out on information. So that again, how would you suggest improving this? Which part of the pipeline would you improve here? Could you take a wild guess? What could be the prompt like? Like what instruction would you, just an example. Oh, okay. So basically giving an instruction that is more generic. Oh,
can add more keywords within the prompt itself.
oh, thank you for bringing that up. Sorry if I hadn't made that clear. So the prompt is actually a static. So if the prompt is static, the method you suggested actually is a good method, but that takes a different agentic approach. But we'll come to that at the end. If the prompt is static, you would have to think about general instructions that makes the LLM look at more information beyond. Again, this is, I don't know, I still don't know if prompting is still a science, but yeah, I don't want to get into that controversy right now. But sorry, yeah.
I was wondering if you could use a better indexer to index your documents.
Yes, absolutely. So there are, I didn't touch upon the retrieval side of things because there are a lot of things that you could go into, but thank you for bringing up indexer, the way you chunk the documents, the way you store it. Yeah, that's another whole rabbit hole, and that rabbit hole is where I did my PhD in. So, but yes, thank you for bringing that up. Sorry, you had a.
I'm not really sure if I'm following the conversation appropriately, but sometimes when I give prompts to some LLMs, and sometimes what happens is I get a short answer, and then I get a comprehensive answer. So is that where you could just manage this? Absolutely. And you are able to capture the nuance so that you get a shorter version, which is crisp, give you headlines, and then you get a comprehensive answer. So if anyone wants to get a comprehensive answer, you can capture the nuance.
Thank you. Yes. So that is one way of getting the nuances of longer answers. So now you've seen how complex it gets as you go in deeper for each stages of the pipeline. So I'm gonna just summarize some of the limitations that we have. Essentially, we saw the wrong retrieval scenario where the retrieve results were wrong. We saw incomplete evidence. We saw unsupported detail. That is basically hallucination, the typical hallucination that we are familiar with. And then there are others as well. I just summarized common 4 that you would face, at least at the initial stages. And yep.
Before we move on to the activity, one thing to highlight here is you could see this limitation, and there is a lot of approach and method we can follow to improve the RAG system. But the hardest thing I found, and I am not an expert in RAG, is that even if I do these methods and I improve the retrieving or the indexing, how do I make sure that the problem did not happen? So in here, it's a simple scenario, and we already can compare the actual documents with the response. But in real life and with actual documents, if you're going to do that manually later, then you could already analyze your data manually or use the methods that you're familiar with. So I think that is one of the biggest issues that we have here, and they're still don't have answer to, is how we actually verify with minimum effort that the responses is accurate or not. Based on what I will trust these responses. Or do my research and my data is not that sensitive and I can be okay with some issues, and to what limits? And also, how do I know if there's an issue or not? Because I need also to declare that the RAG system has been used. And then after using it, how much percent I am sure about the results being generated. Okay, so we did not go into many technical details here because the idea of this workshop is that you understand it's not a tool that you must use it because everyone is using it. It's not something that will make magic for you and will save you a lot of time and will save you learning a lot of other methods that you can use to analyze your data that you've collected. It's just to highlight it is there. It's available, you can use it, but you can also decide not to use it, and that's totally fine because it comes with a lot of limitation. You can also use it for a particular part of your research. You can just decide that I will use it all or I won't use it at all. Maybe you would use it to summarize your data in a particular way, organize your files maybe, but not to draw the final conclusion for your whole research. So I hope that before we move on to the activity, that you have an idea of a RAG system and its limitation, even though you do not know how to build it. And then now, if you decided that it's still useful for you, this is great. Then you can join other workshops and you can watch tutorial of how you can build that RAG system. There are many things you can do inside to improve the retrieval, to improve the responses, but at the end, you cannot still guarantee it will work 100% for you. And you can totally decide that this is not something you would ever be adopting, and that's totally fine. And everyone is using RAG. That doesn't make it a very great thing to use. So the activity for today is going to be a group activity. I would suggest that 4 on each table or 3. And then for the activity, I would like you to take around 15 minutes discussing your research with others, and then focus on one research, maybe something that one of you works on or all of you works on, or something you just imagine and use as an example, and identify these research, these questions, and then think about the data, because the only control you have when you build the RAG system is the data set that you would collect. Think about the data that you will need for this research, and then think if you will use RAG for that. You don't have to have a yes or no answer, but these are the things that I wish you to think about. Are you working with documents that LLM does not train on? Is it a private data or it's a public data that you've collected? Do you need a traceable, citable answer? And I wouldn't say no to this question. But you might have a case where you actually don't care. So when and when not, is your data too large to scan manually or to give it to ChatGPT or Gemini to analyze it? Is it big enough? Can you tolerate some wrong answers and inaccurate information in this research?